Have you ever looked up at the night sky and wondered what will happen to the universe? Will it keep going forever, or will it all just stop? A long, long time ago, about 13.8 billion years to be exact, there was nothing. No stars, no planets, not even space or time. Then, boom! The Big Bang happened and the universe was born. Ever since then, the universe has been expanding like a giant balloon. But what happens when you blow up a balloon too much? Imagine the universe as this constantly expanding balloon. As time goes on, it stretches further and further, with galaxies moving away from each other. This expansion has been happening since the dawn of time, ever since the Big Bang set everything into motion. Now imagine if there was an invisible force pulling back on it, trying to make it smaller. This force would act like a cosmic brake, slowing down the expansion and eventually reversing it. That force is gravity, and it's constantly at play throughout the cosmos. Gravity is the glue that holds galaxies, stars, and planets together. It's the reason why we stay grounded on Earth and why the moon orbits our planet. For the longest time, scientists pondered, what if this gravity is strong enough to pull everything back together? Could it counteract the expansion and bring the universe to a halt? What if, instead of expanding forever, the universe one day reverses course? This idea suggests a dramatic shift in the fate of the cosmos, where everything we know starts to contract. That's the essence of the Big Crunch. It's a theoretical scenario where the expansion of the universe eventually stops and reverses, leading to a colossal collapse. Over billions of years, galaxies would slow down, eventually halting their outward march. The momentum that once pushed them apart would be overcome by the pull of gravity. Then, like a film rewinding, they would begin to move closer. The vast distances between galaxies would shrink, and the universe would start to look very different. Clusters of galaxies would draw nearer, their gravitational pull on each other growing stronger. This increased gravitational interaction would accelerate the process of contraction. Stars would converge, their nuclear furnaces roaring ever hotter as they are pressed closer together. The energy released in this process would be immense, creating a spectacular cosmic show. Ultimately, everything, every atom, every bit of energy and matter, could collapse into an incredibly hot, dense point, a singularity. This singularity would be the final stage of the universe's contraction. This singularity could be the seed for a new Big Bang, a cosmic reset button. From this point, a new universe could emerge, starting the cycle of expansion and contraction all over again. Let's shift gears now and explore another possible fate for our universe, one that paints a rather different picture: the Big Freeze. This theory suggests a future where the universe continues to expand indefinitely, leading to a slow and inevitable decline into darkness and cold. Unlike the fiery end of the Big Crunch, or the chaotic disintegration of the Big Rip, the Big Freeze is a more gradual, almost melancholic fading away of everything we know. Imagine the universe continuing to expand, not slowing down but stretching outwards into the infinite void. This relentless expansion means that galaxies, stars, and even particles of matter are being pulled farther and farther apart. The space between celestial bodies grows ever larger, making interactions between them increasingly rare. In this scenario, gravity's pull is not strong enough to overcome the initial impetus of the Big Bang. The force that once brought galaxies together now loses its battle against the accelerating expansion of the universe. This expansion is driven by dark energy, a mysterious force that makes up about 70% of the universe's total energy content. As the universe expands relentlessly, galaxies would be pushed farther and farther apart. Over time, the night sky would change dramatically. The familiar constellations we see today would be unrecognizable, as the stars that make them up drift away from each other. Imagine looking up at the night sky billions of years from now. Instead of the dazzling tapestry of stars we see today, you might only see a handful of faint points of light. The Milky Way, our home galaxy, would no longer be visible as a bright band across the sky. Instead, it would be a faint, almost invisible smudge. That's because the other galaxies would have been pushed so far away by the expansion of space that their light would no longer reach us. The universe would become a much lonelier place, with each galaxy isolated in its own vast empty region of space. As the universe expands and cools, stars would slowly burn through their fuel. The process of nuclear fusion that powers stars would gradually come to a halt. Stars would first exhaust their hydrogen, then their helium, and eventually, they would run out of all the elements that can sustain fusion. Massive stars would go out in spectacular supernova explosions, briefly illuminating the cosmos before fading into darkness. These explosions would create heavy elements and scatter them across space, but in a universe that is expanding and cooling, these elements would have little chance of forming new stars or planets. Smaller stars, like our own sun, would slowly exhaust their hydrogen fuel, eventually shrinking and cooling into white dwarfs. These remnants would continue to glow faintly for billions of years, but without new sources of energy, they too would eventually fade away. Over eons, even these white dwarfs would fade away, leaving behind only remnants like neutron stars and black holes. Neutron stars, the dense cores left behind after supernovae, would cool and darken, becoming nearly invisible. Black holes would eventually evaporate through a process called Hawking radiation, leaving behind nothing. This process is incredibly slow, taking longer than the current age of the universe for most black holes to evaporate completely, but in the end, even these titans of gravity would disappear. In the Big Freeze scenario, the universe would become a cold, dark, and desolate place, with matter spread so thinly that it would be practically impossible for anything interesting to happen. The cosmos would be a vast, empty expanse, with only the faintest traces of the vibrant, dynamic universe that once was. This is the ultimate fate of a universe that continues to expand forever, a slow and quiet end to all things. Chapter 3. The Big Rip. The universe shredded apart. We've explored the possibility of the universe collapsing in on itself, and the prospect of it slowly fading to black. These scenarios, while dramatic in their own right, pale in comparison to the sheer chaos and destruction that the Big Rip entails. Imagine a universe where not just galaxies and stars, but the very fabric of reality itself is torn apart. Now, let's delve into a fate that's a bit more dramatic, shall we? Picture a universe where the forces that bind everything together are not just weakened, but utterly overwhelmed by an ever-growing, unstoppable force. Let's talk about the Big Rip. This is a scenario where the universe doesn't just expand, it accelerates its expansion to the point where it tears itself apart. Imagine the universe expanding, but the very fabric of space-time itself being stretched, pulled apart by a mysterious force we call dark energy. This dark energy is not just a passive player, it is an active, relentless force that grows stronger over time. This force is pushing everything in the universe apart at an accelerating rate. Galaxies that were once close neighbors are now speeding away from each other faster and faster, driven by this unseen force. In the Big Rip scenario, this dark energy doesn't just keep expanding the universe, it keeps getting stronger, more dominant over time. It becomes the most powerful force in the universe, overshadowing even gravity. As this dark energy grows stronger, it begins to overpower the fundamental forces that hold everything together. Gravity, electromagnetism, and even the strong nuclear force that binds atomic nuclei are no match for the relentless pull of dark energy. Galaxies, once bound by gravity, would be torn asunder, their stars scattered like dust in the cosmic wind. The gravitational bonds that held them together would be no more, leaving chaos in their wake. Stars themselves would be ripped apart, their intense gravity no longer strong enough to hold them together against the relentless pull of dark energy. These celestial bodies, which have existed for billions of years, would meet a violent end. Planets too would be disintegrated, their atoms scattered across the expanding void. The very matter that makes up these planets would be torn apart at the atomic level, leaving nothing but a vast, empty expanse. The Big Rip is perhaps the most dramatic and violent end to the universe we can imagine. It is a scenario where everything we know and understand is torn apart, leaving behind a universe that is unrecognizable, a universe that has been shredded apart by the relentless force of dark energy. So, which one will it be? The Big Crunch, the Big Freeze, or the Big Rip? Right now, scientists think the Big Freeze is the most likely. But here's the thing, the universe is full of mysteries. Every day, astronomers are learning more by studying stars, black holes, and even the tiniest particles of energy. One day we might know for sure. Or maybe the universe has surprises waiting that we can't even imagine yet. But no matter what the fate of the universe is, one thing's for sure. It's an amazing place, and we're lucky to be a tiny part of its incredible story. Thanks for exploring the universe with me today.